Hey, it's G from Outlier. In this video, I wanted to talk a little bit about collaborative robot and safety. So there seems to be a bit of a confusion with collaborative robots and what it means to be kind of safe. They are definitely marketed as safer than industrial robots, but there's many reasons why. And when you think of an industrial robot, like a big robot that can pick up a car or can move very fast, you usually see them in enclosed areas, and you can't, as an operator or just person, just walk up to them. That's because the things they're picking up are very heavy, they can go very fast, and they can just kind of swipe you, and then you no longer can walk, or something very sad like that. So a collaborative robot, right, like I'm standing here right next to it, I don't have any of those cages, but why is that? A few of the reasons are that just the general force that you can hit with someone and hurt them is much lower with a smaller implement. But also there's definitely several safety features that allow it to detect what's going on and to be able to safely work next to someone. So there's a lot you can get into with this, but one of the things I just wanted to show is how a robot can stop itself if it was to run into someone or something. Usually when we're talking about safety, it's someone. Destroying property is something different, right? Okay, so just a little bit of a background, and if you're not technical, that's okay, but the general idea of how a robot can detect what is going on as it's moving is that there's motors in all of these joints, right? And as it's moving, whether it's at some speed, if you were to impede it, it can detect that based on the torque or current that is actually going to the motor. So you can set these different forces in each of these joints in order to put a limit on it and then stop if that joint gets that impedance. So I'm going to do a little demo here that will actually be detected in this bottom joint here, J1, that if it was moving at me, that is going to stop. All right, so I'm just going to go like this, and you can see here that it stopped itself. Obviously, when you're working, you're not going to be moving that slow. And also it was kind of hard for me to demo this, right? Because I don't have this fixture down on a base, it's just sitting on my desk. And so if I was to really push against it, right, the base itself is going to move before the robot would detect that. So that being said, when you're thinking of a collaborative robot application and there's a person that needs to just actually stand next to the robot and do something, there's usually what is called a collaborative space, and the robot moves a lot slower because when it's moving slow, it can do less force or damage to a person that's working next to it. There's definitely also many safety features that you could do, like detecting with the light beam or kind of like a LiDAR laser area scanner to know that someone has entered the space, and then the robot can slow down. But the general idea is that you want to set up your robot to have torque limitations that, for whatever it's doing, will stop it if someone was to interact with it. And that also depends on what you're doing. So if I'm just picking up something and it's like a soft plushie, that might be a very different safety case than it's picking up knives or it's welding. If you're welding, you probably don't want anyone to even get near that. So you might not be using this feature. You will probably want to detect and actually stop everything. So that's just a little bit about collaborative robot safety, and catch you next time.